We're here with Leon with LP Boatworks here in Sacramento, California. We're going to talk a little bit about batteries today: lead acid, lithium, AGM, the differences, the difference in ratings, the different size batteries. So let's talk a little bit about battery size to start with. You got group 24s, 27s, 29s, 31s, the differences, and why you would want one versus the other, especially in a bass boat.
Okay, battery types. There's three batteries we deal with commonly in bass boats. Standard lead acid that's been with us forever, AGM in more recent years, and lithiums, which are awesome. Size matters. On the smaller the battery case size, the less reserve capacity it can hold, which means time for operation on your devices. 24 batteries not going to hold that very well. 27 not so good. 29 much better. 31 for the longest period of time. Use the weight. Heavier the battery is, the more plates it's got in it, the more reserve capacity it's going to have. Now, lead acid batteries have a very high resistance to receiving current flow. They resist that current being shoved into them. AGM is better. Lithium will take as much current as we can shove in it. If our alternator is putting out 50 amps, it'll take every bit of it that the motor's not using until it's fully charged. The current flow will not reduce. A lead acid or an AGM, it can be 25% state of charge. You start your big motor, as soon as you rev it up, its alternator starts putting out full output. It may receive the majority of that current for just a few minutes. It may, say a 50 amp system, it may be taking up, receiving 40 amps. But within 10 to 15 minutes, it'll be 30 amps. A little bit more, it'll be 25 amps, and then 20 amps, and then down to 12 to 15 amps for the rest of its charge time, which takes a very long period of time to recharge that battery. AGM will do a little better. It has less resistance. A lithium will take everything we give it until it's fully charged again. So it's a huge benefit, both on our cranking motors and for our trolling motors. Battery ratings. I like to use CCA, cold cranking amps, amp hours, and reserve capacity. A lot of manufacturers are using marine cranking amps. That's a little deceptive, because if you take an 800 CCA battery that is 800 cold cranking amps, compare it to a marine rated battery, it would have to be almost 1,000 amps to have the same capacity for doing the job. So I like to keep this simple. Stay with CCA, stay with amp hours, which is very common in lithium batteries, or reserve capacity, which is minutes. How many minutes that battery can run and maintain a 9.5 voltage on it. So
now for a crank battery, most of these newer motors require a certain amount of cranking amps, right, to be able to spin them. So that means we have to run a certain battery.
All manufacturers have a specification for that. Mercury Optimax, the minimum is 800 cold cranking amps. That does not include bilge pumps, radios, stereos, electronics, anything. That's the minimum rating for that motor. But experience has also told me if you pump up the cold cranking amps, your motor's going to start better, especially in cold winter days when the oil's thick, the temperature's low, the fuel volatility is low. They're harder to light off. They will crank slow.
Now explain the difference, why the lithiums are so much better than the lead acid on how they draw down. Because we have so many things running on a boat. We got a lot of guys are running 4 graphs now. We got active target. We got live wells. Everything's running, and if we draw those batteries down too far, that's where we start coming up with issues.
Yeah, well, their capacity is much greater. Typically, on a Group 31 size battery, you can see 12 to 1,500 cold cranking amps, which is tremendous for your cranking battery, your starting power. They also, full state of charge on that battery is 13.2 volts. They will stay at 13.2 volts right until the BMS shuts them down. They do not slowly, the voltage does not slowly taper off. On a lead acid battery, as soon as you start using it, the voltage is gradually dropping. So it doesn't stay at 13.2. At the end of the day, you're clear down at 1205, 1210. That lower voltage then requires that it provide more amperage to do the same job. So it's a vicious cycle. And as you cycle those types of batteries below 50% state of charge, you're giving up a lot of life. That battery is not going to last near as long. Where a lithium, you can cycle it all the way down every time out, and you're not going to harm that battery on it. And that voltage stays high all day long, delivering more thrust to your trolling motor if that's what it's used for, or more power to power up your electronics. And as a result, you'll have less voltage drop in your system when you start measuring the drop all the way to the bow of the boat through the electronics wire. That drop won't be as much if you start off and maintain a higher voltage.
I noticed years back running lead acid, when you crank the battery halfway through the day, say summertime where you got aerators running all day, you'd go to fire the big motor up and the grass would flicker, or they might even shut off. Is that a sign of low voltage from like the lead acid days where we don't have to really deal with that with the lithiums anymore?
It is low voltage, and that low voltage comes from two reasons. Not enough reserve capacity in the battery, or not enough cold cranking amps. And then when you crank your big motor, which is going to require a couple hundred amps to spin it over, voltage drop's going to drop 1.5 to 2 volts. Roughly it's going to drop 10%, 1.2 is what our spec is. Well, if the battery's weak anyway, 50% charge, now instead of dropping down to say 10.5 volts, it drops to 9.5 volts. Electronics shut off, the motor cranks slow. Lithium is far less likely for that happen for a couple of reasons. One of the reasons nobody thinks about, it has the ability to pass more current faster than an AGM or a standard lead acid battery will. So it holds up, it will maintain that, try to maintain that 13.2 volts much longer. So when you crank one with a lithium in it, you may see the voltage drop only coming down to 11.5 volts during cranking, where an AGM would show 10.5, or lead acid might show 10. So there's many advantages to going to lithium technology. You just have to make sure it's compatible with your motor. And there's ways to get around that too.
Now you see batteries sold in the same size, like say a Group 29 or 31. One says deep cycle, one says cranking. What's the difference between the two in the same group size on the lead acid stuff?
Deep cycles are designed to be drawn down to a lower state of charge, meaning, hey, it's okay to bring that battery down 75% and recharge it many times. Though it's not good for them, they will tolerate it much better than a cranking battery will. And another example is commercial batteries. Commercial batteries have antimony in them, and if you consistently pull that battery down 45 to 50%, you'll be lucky to get 2 years out of that battery in life, where a deep cycle, under the same conditions, may run you 5 years of life.
Now, a lot of that's going to be dependent upon what we run on our boat. We're getting more electronics, where we used to run 2 7-inch units years back. Now we got 3 or 4 9 or 10-inch units, plus the active target burns power, and plus this and plus that, and hydrowave and spotlight scan, all these different things on there. So we're drawing those batteries down really, really, really fast.
Yes. I have one customer who has to run 2 125 amp ionics to go a full day because of all the electronics on his boat. But his boat, the total current draw for all of his electronics turned on is 24 amps. That doesn't give you a lot of runtime on 24 amp current draw. So I have another video out there on how to design your system, which would be a good one to link to and watch, where I show a spreadsheet on how to design the system, where you'll list everything you've got on it, you'll list all the current draws of all devices, you'll come up with a total current draw on the system and proper wire sizing.
Now this has been kind of a hot topic for a while. Guys talk about it in the 16-volt battery. Why are guys running a 16-volt, and why is it not necessary?
Most guys are doing that because somebody told them, oh yeah, your screens will stop flickering and will stop turning off when you start your big motor. And that's true if your wiring is insufficient or your battery is too small. Putting in a 16 volt is starting at a higher level, so the voltage drop is not near as great as if you're on a 12 volt system.
Just a quick topic off of that. What typically causes, when you go from the battery to your electronics, what typically causes that voltage drop? Because that's why guys do it, is because they see that voltage drop.
That's too small a wiring. In most cases, they're using the original wiring that came in the boat, and especially in older boats, the wiring size is considerably too small to supply what we are demanding from it today. And also the connections. A lot of these connectors are push-on connectors, which really develop a lot of resistance to current flow. We got to get rid of all those unnecessary connectors, got to get rid of all that unnecessary wires, and run a dedicated circuit for your electronics that goes straight from your battery in the bilge up to a fuse box in your console area, and then from that fuse box you will make individual runs to each device you have. This does several things. It gives all your fuses in a central place, and you get rid of all those inline fuses that you forgot about where they were even located, and it gets the wire sizes upsized for higher current capacity, therefore you have a lot less voltage drop. I talk about this a lot in the other video on how to plan your system.
Is a dedicated electronics battery really necessary? I see a lot of guys talking about it online, some of the chat groups, really running a dedicated, they have to have it because it's the only way that they're going to get a really clean picture on their graph. Is that really necessary?
Yes and no. For the most part, no, it's not necessary if your wiring is done correctly. And when you run those wires, you've got to twist the wire power ground pairs, as twisting the wires cancels interference and EMI that's in that wire, cancels it out. And shielding it. And shielding is a tin copper mesh shield. You slide over the wire, you attach your ground to it, and you ground that to the negative terminal on the battery. That shields the wire from receiving RFI or transmitting RFI, which is a big benefit.
All right, guys.
We got more.
Oh, we got a little bit more? All right.
Actually, a little bit more, yes. On the house battery. In cases of where you have a stator ignition, a house battery can be a very good, a stator charging system, I should say. A house battery can be a very good aspect because you add it separately from the cranking battery on it, and all your electronics run off of it. The problem with the stator type system is if you run it on a lithium battery or even an AGM, the current flow will be too high in the stator system. It will overheat and will self-destruct, especially in a long run in a discharged battery. So we don't recommend either of those two type of batteries in stator system. Standard lead acid only, because that standard lead acid battery has a high resistance to charge rate. And because of the design of the stator system, it has to do with permanent magnets versus electromagnets. Permanent magnets cannot control current flow. Therefore, the system will self-destruct. That low resistance lets it pass too much current and burns up the bobbins in the stator, burns up the regulators, burns up all the bullet connectors. Don't do that on a stator type system such as the old EFI motors. A lot of them were around pre-1990. Pre-2000, a lot of stator systems were used. You don't want to connect those to a lithium or an AGM battery.
So any of the newer Optimax motors, the new SHOs, the newer Yamahas, basically anything built after 2000 would probably be fine running the
That's
lithium.
a really good question, because you will find Yamahas are having more of a problem with the mercury with lithium batteries. As a whole, they're not recommended, though some they are. Mercury has now put their blessing on lithiums on the newer motors, but not the Optimax motors. There's an easy way around that on it, and that's to put in a house battery, connected in an AGM house battery. It can be a small one, doesn't have to be a big one, connected in parallel to the lithium. And by doing that, you avoid the possibility of the BMS shutting down and taking the battery out of the circuit. If the BMS shuts down, your motor shut off. And this could be a big surprise to you if you're running somewhere and all of a sudden the motor turns off at an inconvenient time. So this is why a hybrid system with a lithium paired to a AGM works very, very well. Both batteries will actually benefit from that, as the depth of charge will not be near as great, and you're constantly trying to bring up the AGM battery to the lithium's level, and you're constantly trying to bring down the lithium state of charge from its peak. Both batteries benefit from that.
Oh wow! I've always been told that you can't run a lithium or lead acid or AGM in parallel together. That's good information.
It works. This is what hybrid system's a well-proven system, and it was working out very, very, very well. Now, to add a little bit further, we've been running a lithium ionic 125 on a mercury 2-stroke for 4 or 5 years now. Never had a single problem. I have hundreds of customers that are running lithium batteries on the 2-stroke. Not any of, only one customer I have had a problem with running a lithium, and that's on a Yamaha motor. And Yamaha has obviously had more problems with shutdowns, either idling or running, especially if the battery is near full charge on it. The BMS senses a voltage spike and it shuts off the battery and immediately turns the motor off. Well, the fix for that's to have an AGM connect in parallel to it. That way, if the BMS did shut off, it still has an AGM in the circuit, and the motor is not even going to notice it. Won't be a problem. This is an inherent problem, in my belief, in Yamaha's charging system, causing a voltage spike that exceeds 15 volts. It's turning that BMS off on it. I don't. No, it's not a problem with the battery. It's a problem with the design of the charging system on the motor.
That hybrid system you talked about, that brings up another good question: is the difference between running a single 36 volt or running 3 12-volt batteries in series. And the advantage of that, if you have a battery fail or something like that, you'd be able to throw a lead acid in there instead of, if you have a single 36 fail, you're kind of dead in the water.
Yeah, but don't confuse what he just said with hooking your cranking motor to a trolling motor battery. Don't do that on it. That's not what he meant. I understood what he said, but somebody else might misunderstand that. A hybrid system is just pairing another battery to a lithium for cranking purposes and your electronics. But remember, when you do that, you can have tremendous amount of battery capacity, and the depth of discharge on the batteries is quite low on it. For my boat, where we run generally pull it down 40, 50, 60% in a day, if I did that, we would only be pulling the batteries down 20 or 25% in a day. The AGM really benefits from that in extended life, so that AGM may live twice as long, and when it's paired to a lithium battery.
Yeah. Well, I think we about covered everything we can on batteries today. Thanks for tuning in. If you enjoy the video here, give us a thumbs up and a like and subscribe. We'll see you next time.